Hello everyone, my name is Giovanni Sanchez and I'm a part of Group 4. My team members are Dominic, Emily, and Rebecca, and today we're going to go over unit testing, where we're going to define unit testing, describe its background, the importance of unit testing, the advantages and disadvantages of automatic and manual unit testing, the best practices that exist with unit testing, the unit testing frameworks that exist, and the several issues that we may encounter whenever we play around with unit testing. We decided to cover this because it caught our attention and we noticed how important it is for us computer science majors to know about this topic and how it'll benefit us later on in our careers. Alright, now let's start with what unit testing is all about. Alright, so what is unit testing? Unit testing is an important step in the development process that focuses on individual units or components of a software system. If done correctly, it can help detect early flaws in code, which may be more difficult to find in later testing stages, all of which can make the development process seamless and less stressful for the developers. The main purpose of unit testing is to isolate written code in a way that it can be tested and evaluated to make sure that it's working as intended, as well as seeing if it's meeting given requirements. Unit testing is essentially done by developers and it's performed in early stages of the development process to make sure that everything is working fine, and this is done before the code is integrated and tested as a whole system. The sole reason we want to ensure that we utilize unit testing is because it will allow us to deliver high quality programs and systems for anybody that we may be collaborating with, and it essentially helps us find any issues early on without having to worry about our systems breaking down or having any unexpected error later on in the development process. And for this reason, we want to utilize unit testing and essentially deliver an effective and wanted product. Now Rebecca's going to talk about the background, usage, and importance of unit testing.
Testing code is an essential part of producing a working project. Sometimes programs and software we're developing can be hundreds of lines of code. Scanning through all those lines of code could be a daunting task and take hours, only to find out it is one minuscule part of the code that is causing the entire program to fail. That can be difficult for people to deal with and may cause them to lose their focus and their passion for the project. While we as programmers should be testing and fixing bugs as we move along in the coding process, it may not be entirely possible to foresee an issue with a function or a class or whatever feature it may be. And as we add more code to a program, it becomes more complex. Wouldn't it be nice to have a feature to test small parts of code once the entire program is created? That feature does in fact exist, and it is called unit testing. I'm going to talk a little bit about why unit tests are used and cover a brief history of unit testing. Before unit testing, people relied upon capture and replay testing tools. The capture and replay tool records input during the manual testing process in order to generate an automated test script that may be used for later testing. In 1997, Kent Beck created JUnit. JUnit is a development environment plugin used to test small pieces of code. This allows developers to write test code to assess the source code. Martin Fowler released a book named Refactoring, which is about transforming code to make it more isolated and testable. With the release of this book, and with the development of unit testing, programmers moved toward a test-driven environment. Unit testing became an essential part of the development process. I am now going to talk a little bit about why unit tests are used. Unit testing allows quality assurance engineers and developers to check the performance of pieces of the software immediately after it is written. This could save valuable time and money. Fixing bugs without running tests could introduce unforeseen bugs to the application. As code becomes longer and more complex, it is more vital to the process that bugs are found and destroyed in order to save time going back and looking for a bug, and to save money in case the application rolls out with major unnoticed bugs. That is why unit testing can come in handy. It can significantly simplify the debugging process. Unit tests allow engineers to test a small portion of code and find the issue quickly, or at least to narrow down where it could be coming from. Unit testing mainly allows software developers to know their source code works at an atomic level. It allows them to isolate a class, a function, or method to only test that piece of code. This allows programmers and engineers to be able to make small changes and test those changes, making for much faster end-to-end integration. These tests can also act as documentation for the code. Executing the unit test with one configuration of the code may lead to one result, while a different configuration could lead to another unexpected result. This could be useful to keep records if one configuration could prove to be helpful at another time, and the programmers need to find it. Unit testing could serve as documentation to help locate and to help replicate the code. These are just some of the several reasons why unit testing is used. Legacy software refers to software that has been out and running in the world for an extended period of time, years, decades. Usually, these legacy softwares are written without unit tests. This legacy code holds a lot of value to companies as it continues to process and control transactions every day that result in millions of dollars worth in revenue. Typically, code without unit tests are not organized well and can be challenging to understand just by looking at it. Usually, these companies tend to hire several different maintenance programmers to update the code to today's standard while still maintaining their old integrity. They usually make the most minor change they can, so they won't have to deal with compromising the rest of the program. Without unit tests, there is no way to know how the rest of the program will run with significant changes. They use refactoring to make changes piece by piece in order to make the program testable. So they spend most of their time in test maintenance and spend less time optimizing the code rather than making it work properly. Unit tests would allow engineers to make significant changes, test them, and make a significant impact on the performance of the program. However, it could be argued that adding in unit tests to the legacy applications is far too expensive. In order to incorporate unit testing, it would be far more efficient to create a whole new application that supports unit testing. This does depend on the language, however. Applications that are written in modern languages such as C++, C#, Java, etc., can go back and retroactively incorporate unit tests through refactoring. While this may be time-consuming, it could also be far less expensive. Some people are stuck in a fixed mindset. They argue that we're adding to one area of programming, those being the quality, amount of work done, the resources, the time, they must subtract from another one of these areas. These people are scared of new ideas and change. Utilizing unit tests effectively can help to break the rules. Having unit tests helps to create testable code, which will greatly increase quality and performance. Unit tests are also extremely helpful when a bug is found, as they lead to much faster debugging. The way unit tests are written allows for the bug to be less likely to repeat. Unit tests are proven to significantly increase the process of development of applications. Working on a project as a team can seem like a lot of work without the use of unit tests to test one another's code. I am now going to discuss the importance of unit testing, mainly in the workforce. Why is unit testing valuable in the workforce? One reason is in order to maintain orderliness and strictness. IT managers must ensure that their team stays on task and that they are executing their task at the highest level. Staying on top of a team and ensuring that they consistently and effectively use unit testing. Using it will ensure that the process will stay orderly and that the testing rigor will continue for the rest of the life cycle. I will now continue to talk about the next point here, which is, will the software function? Testing as a whole ensures that the outcome is what is expected. This can only be done as the testing period goes on. The unit testing phase is the first step in this journey. Unit testing won't necessarily determine the outcome of the software entirely, but it will help with every interaction in the build test by allowing for programmers to test it in parts. The next one is to lower the intricacies of software metrics and circuits. As more code is added, it can make it much harder to achieve a good measure of unit test coverage. Ensuring good code coverage will save from redundancy or unnecessary lines of code. And unit testing can help with this. Testing small portions of code can display the coverage for certain functions, methods, etc., and to help the engineer determine what is needed. The next one is to make sure the software is tested before delivery. This one should be obvious. Unit testing is a great way to make sure all software is tested before it is delivered to the world. Rapid implementation is a recipe for failure. Unit testing can be a way to know if a software build is up to par. Next is documentation. I touched on this a bit earlier. Documents and articles are usually needed to decipher a system's components' workings. It can be tedious to write all these documents. Here is where unit testing's benefits can be reaped again, as the documentation made during the unit testing phase show exactly how the build and the components are supposed to function. Next is code coverage. As mentioned briefly earlier, code coverage is optimized with the help of unit tests. Unit test tools can provide measurements on the code range. If code were to be unused and there is efficient test coverage in all the other areas, this code could be scrapped. The next one is performance rating. While working on a list of things to do, engineers may find themselves in need of information such as the operation's success rate. If performance tools are unavailable to them, unit testing results could serve in their place. As a list grows, it must be evaluated. Unit tests can help to gauge performance ratings. The last one gives the possibility for continuous integration. For a bit of context here, let me explain a short little scenario. Say a team of developers are working on a project, and each person has access to a specific area for them to work on. If one developer were to make a change that would affect the whole system, no one would know. Without unit tests, this would be a disaster. With unit testing, they would be able to quickly find the issue and to resolve it. This is a little bit about the brief history and the importance of unit testing.
My name's Emily, and the first topic that I'll be talking about are the two types of unit tests. The first type is automatic unit testing. Its primary focus is to reduce testing efforts by making it faster and more affordable. In the bottom right corner, you can see a picture that has an example of tools that are used to automate these tests, such as JUnit, NUnit, and Jasmine. So what is automatic testing? It uses specialized tools to test scripts automatically, and it executes pre-scripted tests that compare expected results with the actual results that you get. It is widely accepted because it improves testing speed, output, and breadth of tests, and its quality relies on how well written the test scripts are or the specialized tool used. Some advantages of automated testing is that it's more cost effective because you don't rely on as many people. You really only need a couple people maintaining the software and the tests themselves. It also takes less time because you're not spending as much time creating or exploring tests that you could use with your code, and it leaves more time for maintaining the test scripts instead. It's also reusable. You can reuse it across several versions of your system, so as it evolves in the future, you don't have to change the tests along with it. It also improves reliability. You can repeat the test cases and weed out unseen bugs. Automated testing makes it easier to do repetitive tests in a higher frequency than if a human tester was doing it. And so some of these bugs may go unseen if a human tester was doing them instead. And it reduces manpower. Like I said earlier, less people are needed to create and maintain these test cases. Some disadvantages of automated testing is that you'll need professional level testers to maintain these test standards. Entry-level testers might not fully understand the test standards that are needed for these tests, and you don't want to use non-standard tests because it's not reliable. It may miss a lot of errors and mistakes, and some of these professional level testers may be hard to find and hire. Another disadvantage is that debugging is still required. Mistakes can still get through. You can have deadly consequences if you miss them. Maintenance costs are quite high. You'll need expensive equipment, which goes into my next point, is that you'll need top-notch testing tools. You don't want to use a cheap, unreliable tool to do these tests. And not all testing tasks can be automated, which I'll talk about with manual testing. Its primary focus is to identify bugs and defects, ensure the product is error-free, make sure it conforms to specified functional requirements. So what is manual testing? These are test cases that are ran by a tester in the end user's point of view. It is used to check to make sure the program runs in accordance to the requirements and provides timely feedback. It also guarantees that the program is free from bugs. The tester is going to have to make sure that all bugs, all defects that might inconvenience the end user are gone. So they have to delve in deep with the testing to make sure everything runs smoothly. It also improves a testing engineer's ability to develop test cases. It is often required before any automated testing, and understanding manual testing methods are more necessary than understanding automated testing tools. You won't always have these tools to do your tests, but you'll always have yourself. So a developer will need to be able to create, maintain, and run these tests in the case that they don't have a software to do them. Advantages of manual testing is that the tester assumes the role of an actual user. It's easier to find any UI flaws, and you can test usability for the end users. It's easier for new testers to understand. Sometimes the software can be complicated, and so for new testers, manual testing is typically what they start with. It also guarantees there are no flaws in the program, like I said earlier. It can evaluate GUI designs that change dynamically, and many testing tasks cannot be automated. Like I said, with automated testing, there's a lot of portions of a system you can't test with automated testing, such as usability, ad hoc, exploratory testing. Some disadvantages of manual testing is that it's not reusable. Each software is unique and will require their own test cases. It is time-consuming and requires a lot of effort. You need to spend a lot of time creating, maintaining, and making sure the tests actually work with manual testing, and so it's going to take a lot more time and effort. and some functions may be missed. Test cases are manually written, and sometimes testers will miss smaller functions or just overlook some functions as they're focused on other parts. And not everything can be tested. It requires more people to accomplish because you'll have to have people creating, maintaining, making sure everything's running smoothly, and all that. It also requires collaborations between two teams. They may not be able to match each other's pace. So you have the developer team, the testing team, and sometimes they may not be able to communicate clearly with each other. Some best practices of unit testing is the next topic. The first best practice that you want to keep in mind is that you want to keep tests fast. Faster tests have a higher likelihood of programmers actually using them because slower tests tend to be avoided. If you're developing something and it's taking 5 minutes just to test whether your add function actually works, you're going to avoid it, and you're not going to test whether it actually works or not. And these tests are supposed to be like safety nets, and it defeats the purpose of testing and promoting changes to code if it's slow and it's avoided. So how can you keep it fast? You can keep the code simple, avoid creating dependencies on other tests, and mock external dependencies. The next best practice that you want to keep in mind is that you want to keep it simple. Simplicity of test code allows for better testing for behaviors. It becomes a lot more resilient to future changes in the code. Because it's so simple, there's not a lot of complexity to it, you don't have to change it as often, because as long as it's focused on that one behavior, it doesn't need to be changed, even if the production code is changed. And complex tests have a higher chance of introducing errors instead, because the more complex it is, it might be easier for the developer to miss mistakes that they've made in the code. And if the code still passes incorrectly, it'll make the developer think that everything's running smoothly, but instead they just missed a bunch of errors that just went through. It also makes the intent of the test less clear. It's easier to see what's going on if it's simple. There's not a lot of complexity to it, and so if it's more complex, it's harder for developers to understand what's actually going on with the test. So how can you keep it simple? You want to avoid extra properties, unnecessary variables, values, etc. And you want to keep focus on a single behavior. You want to test multiple behaviors in one unit test, because these unit tests are supposed to be isolated. They're supposed to be very simple and focus on a single behavior. And the more behaviors that you're testing in one single unit, you're gonna go towards more testing for implementation, which you don't want to do with unit tests. You can also measure the cyclomatic complexity as well. Here's an example of a bad and good test, or a simple test. In the bad one, you can see that they're using a bigger number. Sometimes bigger numbers may make it harder for the developer to understand what went wrong. So you want to use simple numbers. So the 0, you may be able to understand if something does go wrong, where it went wrong, and how it went wrong. You also want to keep these tests deterministic, because developers trust deterministic tests more. And what it means is that a test should present the same behavior if no changes were made to the code under test. Essentially, the test should always behave the same if the test code hasn't been changed. So if it's always running true, and as long as the test code hasn't been changed, it should remain running true. And it only switches behavior when there's a change in production code. A test that sometimes fails, sometimes passes, even though the test code hasn't been changed, is unreliable. And testers will avoid it, and sometimes they might even just avoid testing that portion itself. And in order to make it deterministic, you want to isolate the tests. You want to avoid dependencies on other test cases, environmental values, and external inputs. The next best practice that you want to keep in mind is good naming convention. Standardized naming explicitly expresses the intent of the test. It provides documentation of what is in the source code, what has been tested, and it also allows developers to understand the behavior of the code quickly. Sometimes they just want to look at it and quickly understand what's being tested and what behavior it's focused on. And you want to make the naming convention easy enough that even non-developers should be able to infer the behaviors. You want to choose a convention that is easy for everyone in the team to understand, and you want to clearly communicate the intent of the test. You also, a suggested convention is that the test name should consist of 3 parts: the name of the method being tested, the scenario under which it's being tested, and the expected behavior when the scenario is invoked. Including these 3 parts when considering the name of a test will allow for its intent to be clear and communicated to whoever is using it. You don't have to use this convention, but as long as you can use any convention as long as it's clear and can communicate the intent of the test. Here's a good and bad example. The bad example, the name of the test is called test single. It doesn't really explain what's going on. It doesn't explain what the test is for, so it's not a very good name. In the good example, you can see it's add, single number, return same number. It shows you what method's being tested, how it's being tested, and what you should expect the test to return. Another best practice you want to keep in mind is that you want to have a good arrangement. A common pattern that developers use for unit tests is the range, act, and assert. It clearly separates what is being tested from methods and the output. It improves readability of the test as well. It highlights dependencies required to call the code, emphasizes how the code is being called, and reiterates the expected output. It's usually easier to debug because each test is an isolated unit and everything's spread out, so you can see the different parts of the test. And so if it's broken, you'll be able to see where it could have potentially have messed up. And here's an example. The first example, the bad example, shows that the assert and act were put together. And it's not bad per se, it's not the greatest, but when the good example, you see that they're separated, and so it's easier to see what's going on. It's easier to see what the different parts, and if anything goes wrong, you can pinpoint where it could have went wrong a lot easier. And the last best practice that you want to keep in mind is to avoid logic in your testing code. This reduces the chance of bugs being introduced into the test. You want to avoid string concatenation and logical conditions, such as if statements, while statements, switch statements, and more. You want to focus on the end result and not the implementation. You want to focus on what behavior that you're getting and not how it's getting that behavior. And you want to have a high level of confidence in these tests, and tests with implementation have a high risk of including bugs. And tests with bugs are not reliable, and then of course it'll lead to testers maybe avoiding testing and all that. And a tip to avoid logic is that if their logic is unavoidable in your test, you want to try splitting the test up into 2 or more tests.
Hello, my name is Dominic Bell, and I will be showing you some examples of unit testing. So to start off here, we have a program that emulates banking. Here you can create objects. You'll have a name and a balance for an account, and then just another simple transfer function, so you can transfer money from one account to another. So here, this is like if you had your actual program, what you're doing work on. You have your classes and your functions, and we have that in a a file called project.py. A small thing to note here, because we'll use it later, is if you try to transfer more money than you currently have in the account, it'll throw a value error. So for our first example here, this is how a lot of people probably are familiar with. They already do unit testing like this. So you create a program, and now you need to see that it works. So here we're just creating 2 accounts for Bob and Joe, and then we just want to transfer $20 between them. Just to make it easier, we threw them up in we threw values up here in variables. Sorry, I'll keep pausing because I'm not very good at public speaking, so pausing makes me less nervous. So we threw variables up here for balance 1, balance 2, how much we want to transfer, and then we use that here to make 2 accounts. So first account has 100, second has 50. Then transfer always transfers from the first input to the second input, and then the amount up here we set to 20. So if we look at it, we should go from 100 to 80, and then this 50 should go to 70. And then down here is where we do a test. This is where you've probably done something similar. You probably just did a print statement. That's what I usually do, but slightly more in depth. Just an example: did the first balance transfer work? If not, print a statement just saying there's an error. Same with the second one. And then if they both did work, just say the values are correct. So go ahead and run that. So it says we have transferred the 20 and the account values are correct. This is totally fine for smaller projects, but if you want to use something more like JUnit that we used in our class, Python has a built-in test case library already that we could use. So here's another example, same as the last one pretty much. We have to import project, which is where we just did our class and our function. The last one we just did all of it inside of it ourselves with print statements and ifs. This one we're going to import unit test. And you can create a class called testing, and then you have to throw unit test in here. And then every groupings you create here will be a test. And it has to start with test underscore to be recognized. And then this is where you're supposed to name it something. Name it something so that you kind of understand what's going on. So this one's just a basic transfer, just like the first example here, except it's done through this unit testing framework. So same example with Bob and Joe, except this time they both have $100 just to kind of standardize it for all the tests. And then the basic transfer is just something that's within the limit, the most common example you'd expect. And so we just do a $20 transfer, and then we do the assert to make sure that the new account balances are correct. And this is what you're used to in JUnit, what we did in our class. So if the balance is 80 from the first one, because 100 minus 80, or sorry, 100 minus 20, and then the second one should be 100 plus that 20, and as long as these are true, this test will pass. And then another example, just have different test cases. This is if you transfer your entire amount, which for this project works totally fine. But what if it was more specific? Like a lot of banks require you to keep $5 minimum in your account. So if that was one of the requirements for this, it would be included in the project or in the specifications. And somewhere we would have a rule saying you have to have $5. So that would throw an error here if that was a problem. But since it's not, this one will also run fine. Just double checking, balance is 0 since you're transferring the full 100. And then this balance should be 200 for having both amounts. And then this is the kind of interesting case. So we want to see how you can test if an error is correctly thrown. So we've shown previously here that if your balance is less than the amount you're trying to transfer, so if you were going to go below $0, you throw an error. The value's not good. For Python, you can throw a value error. And then you can put the statement here, so just saying that. So here, use this different wording, which grabbed from the Python documentation, where you use with self-assert, and then you want it to raise the value error, which was the keyword that we used back here. So that's important there. And then you just do it just like a generic test, just like the other ones. You create 2 accounts. You try to transfer more than you can. So here we try to transfer 200. You can make that anything as long as it's over 100 though. And then that's this test case. So there's 3 test cases. A normal transfer, transfer everything, and then transfer more than you can. And then for it to run, you throw this little thing here. It's from the documentation as well. And then you just run it. So it'll say ran the test. You get the print statements from the other ones because that's part of transfer. I threw this in here earlier just to double check things, but it doesn't really matter. And then as long as all 3 tests run correctly, you'll get an OK. But if you have one that doesn't work, so let's say this one we only transfer 50, so there will, since this is within bounds, there will not be a value error. So we go ahead and run that one. And it'll say there's a failure here. And then you can go ahead and scroll up a little bit and see where the issue is. So it'll say line 26, which was this test. It'll say a value error was not raised. And then you could go back and see why. So this is nice just to keep things more compact. It's also really easy whenever you want to create new test cases. So like right here, if we just want to throw another one in and make this test negative transfer. And then, so we have the usual 100, 100. What if we try to transfer negative 50? So we know logically the 100 minus 50 would actually go to 150. And then you'd be taking it from the other account. So instead of going up, this one would go down. Could do a test case here, and then we'll just see how that runs. Oh, the slash is how I pause and unpause, so sorry about that. So it still has an error because of this previous example that I didn't fix. But that is the only error. The other test worked fine. So go ahead and run that again. So all 4 tests are okay. So it may seem a little weird that a negative transfer works, but that's because, as a reminder, unit testing is all about input and output. The actual code isn't really our problem. It's double checking that you get what you should. So because this is how transfer works, he just takes an amount, it doesn't care positive or negative, the output is correct. If there was an issue here and you don't want this functionality, so like you actually wanted it to throw an error, then that's where you'd have to go through and change the actual product. But that is not the actual testing. Unless you were, say this was a program you were given for a class, then you wouldn't have worded the test this way. You would probably do the same thing here where you say there's a value error. So if we want to go ahead and try that, oh, I didn't change this wording earlier. Transfer a negative amount. So if we're saying because we threw 50, there should be a value error, just say that was part of the program specifications, so that's what we were testing for here. Then this is how you would word the test. So wording, how you create the test also matters. So you just need to be aware of that based on what you're doing here. So now we're saying, in this example, we want the test, we want the functionality to be that if we try to transfer a negative amount, or in this example, a negative amount, then it should throw a value error. But it doesn't, so we can check that this test failed. Value error not raised, line 25, which we can see is this test negative transfer. So this is where you could go here and start changing things. Alright, so I threw in a test here to say that if the amount, which is the parameter here, is less than 0, then now we will throw a value error. And then a description that doesn't really matter, and it's probably too long, but there you go. So we save this, go back to our example, and see how it works this time. So this time it does work, which means the assertion for the value error is correctly working now. So we wanted this to fail, now it does. So because we ran this unit test, we saw where the error was, we knew where to go fix it in this example. So usually this will be like if you're given an assignment, what you need to do, or something for work, you want to test all your cases. And this was just a negative example here. So I believe I mentioned it before, but this unit testing, it's not like some of the others where you have to download it as an extra extension. It's included in Python already, it's just called unit test. So here, if you want the links, if possible, we'll include them in the video description. Alright, sorry about that, I got a phone call. So it's built in, there's the documentation, has some good examples. And then I also looked up other examples, so I found this free codecamp.org link, and if you look through that, you'll see similar to a lot of this. I used that free codecamp link to make, let's see, a lot of these examples. I used the formatting, and then just saw how they use the assert statements. Definitely helped with creating the raising errors type examples, so just want to give credit to them. Then for this last example, I want to show direct input from the end user side with no code. This is also a part of unit testing. And then I just want to use an example actually from a program I did this semester, which also helps because I can't show the code because it's a program that I did in class, but we're not going to look at the code, so kind of works there. So I'm just going to show that's part of the specifications. It's a lexical analyzer, I believe, where you can take inputs and you just want to see if all of the items are allowed. You don't care about any other details, just if they're allowed. So here it's like numbers, operators. See if my mouse shows. Here we go. So digits, like plus, minus, identifiers, which would be like variables, keywords, and then comments. So let's go ahead and throw this up here. So this just shows the folder, and then just simply running the program. See if we can get this to fit correctly. Yeah, that works. So this was just a program I had for a class, and then so you just want to direct input testing. We have the end program, does it work? So numbers, operators, identifiers, keywords, and comments. And then so there it says all tokens valid. You can see every line, show that everything works. And then you can throw a failing example. So, you know, all of this is fine, but then it never says you can use, let's see, you can't use exclamation mark, you can't use period. So the first time we run into an error, it says not recognized, program ending. That was just something I included. And then this is where direct input testing comes. And as you can imagine, it's very slow and inefficient, but it can be a good last step. I imagine a lot of students do the same thing before they turn in an assignment. They want to just double check things work from this side of things, from the actual program running. No code included. This also happens in companies where you just need to double check that as an end user, so this is the program you received, whether or not inputs work. Because again, unit testing is just input and output. We gave this input, does the output work or not? Alright, but that's everything for me, so I hope these examples were helpful to you. Thank you.
Alright, now let's talk about unit testing frameworks. Alright, so the first batch of unit testing frameworks that we're going to talk about are in C#. The first one is NUnit, and it's a popular open source unit testing framework for C#. It's ported from JUnit, and it's used for the development and execution of tests through the .NET language. It helps facilitate batch execution of tests to the console runner. And the console runner essentially helps in loading, exploring, and executing tests with the help of the NUnit testing engine. The next one that we have is XUnit.net, and it is also an open source testing framework, and it's based on the .NET framework. With this one, it's basically known for its intuitive terminology and extensibility, and it divides given tests into facts and theories. The next unit testing frameworks that are worth mentioning are in Java. The first one is JUnit, which is an open source unit testing framework for a test-driven development environment, and it's also a part of the XUnit test frameworks family. It supports the core concept of first testing, then coding. The next one is TestNG, which is an open source automation testing framework, and it resembles JUnit and NUnit, where it supports concurrent testing and annotation. And this one has a powerful execution model with the test configuration capabilities. Alright, the next unit testing frameworks that we're going to mention are in C or C++. The first one is Embonet, which is an open source unit testing framework, and it's designed as a unit testing tool for both developers and testers. For this one, there is no need to write any code, and instead you just do tests that are specified as a list of actions. The next one is Cantata, which is a Dynamax testing tool for unit and integration testing. For this one, it allows the developer to have reusability and allow them to perform testing for large data sets. And for this one, tests are generated by parsing code to all interface control. Now, the last unit testing frameworks that we're going to talk about are in JavaScript. The first one is Mocha.js, which is one of the most popular JavaScript testing frameworks. It operates on Node.js and provides front-end and back-end testing compatibility. This one possesses firm documentation support. The next one is Jest, which is a JavaScript testing framework used and maintained by Facebook. And this one provides zero configuration testing experiences, and it is based on React. This one provides features like snapshot testing and built-in tools for code coverage. Now we're going to talk about some problems that we can encounter while doing unit testing. One of the first problems that we can encounter with unit testing is whenever we write the wrong type of tests. And this occurs whenever our tests are really long and they fail for strange reasons, that we tend to find several bugs during our whole development process. And this is probably the most documented problem related to testing in general, where people tend to write very few unit tests and too many system tests. And whenever this is done, a lot of times tests are just done to target a specific type of behavior, when in reality, programs can have several behaviors and they can differ from one another. So as developers, we have to ensure that our tests are suitable for any type of behavior that may be occurring with our systems. Another problem that we can encounter with unit testing is whenever our test names don't communicate exactly what they're supposed to do. So this occurs when the test names don't necessarily describe what they are doing, and the name basically doesn't align with everything that is intended to be done with that specific code. So naming tests is essentially one of the most important things you could do as a programmer. And if it has a different name that isn't really aligned with what it's supposed to do, it could be very misleading for the developer and cause several issues during the development process. Another problem that also occurs during unit testing is whenever developers carry out debugging tests too often. So whenever a developer finds a test, they instantly jump into the debugger to see what's going on with their code. However, tests should be simple and easy to understand so that developers can easily spot out any errors and possible failures that may be occurring with the code without even having to open the debugging tool. That way they have an easier time during the development process. So the last important unit testing problem that we can encounter is whenever we allow test codes to rot. So this occurs every time we don't understand a code and we decide not to change it until later on in the development process. So as developers, it's ideal for us to change it right away in a way that we can understand it so that we can easily spot out any defects and issues with the code early on in the development process and not have to do it later on. During this presentation, we went over what unit testing is, its background, and why it's important for us, as well as the different types of unit testing that exist. And we also covered the advantages and disadvantages of automatic and manual unit testing, as well as the best practices that we can follow whenever we do it. We also went over the different unit testing frameworks that exist and the several issues that we can encounter whenever we carry out unit testing. Now we should all be familiar about how important unit testing is and how it'll benefit us later in our careers. We learned that it helps us find bugs within our code, verify that our code is functioning properly, and also learn that it's a good way to maintain our systems to ensure that it's functioning properly, as well as knowing that it's a good method and way to ensure that we all have functioning systems that will be very useful for ourselves and for all our colleagues that we might work with. Overall, it is safe to say that unit testing is an essential practice in software development and in any environment that requires testing and that uses any type of system that manages data. And it's a valuable skill for many of us computer science majors to develop in order to create high quality software and improve our own ability to develop these types of applications. Not only that, but I feel like it's very important for us to put into practice this type of testing mechanism because it'll benefit us in many ways and it'll eventually open many doors for us, give us many job opportunities thanks to the skill set that we might develop by using this mechanism. And also, it'll make us get used to practicing methods that'll allow us to always produce and ensure higher quality software. Alright, this concludes our presentation over unit testing, and we hope that you learned something new and you learned about how important it is to apply this mechanism into your lives, and as computer science majors, how essential it is for us to know about this in order to have more successful careers later on in our lives. If you guys have any questions for us, feel free to reach out, and thank you so much for your time and attention. We hope you guys have a great day. Bye-bye.